What we typically see for needs on alkaline is a type 2 or type 3 water, usually better than 1 mega ohm, 1 microsiemen, depending on how you look at it. So the water requirements for that are a little bit lower than what we would typically see for, say, a PEM style or designed technology electrolyzer. So I will have to make a distinction, I guess, when we're talking about alkaline versus PEM. So for both systems, there will be what we would consider to be a makeup water system. And the makeup water system would be, depending on the feed water, would have pre-treatment, typically reverse osmosis, to do a bulk of the removal of ions, and then some type of deionization process in order to get the mineral content out of the water. So the makeup system generally needs for that are pretty well known, about 0.2323 cubic meters per hour per megawatt. So that's typically what we'd need for the makeup. And again, for alkaline, that would pretty much be all we needed for the treatment process. We'd make that type 2 or type 3 water better than 1 mega ohm, somewhere in that neighborhood. And that would be the water consumed in the electrolysis process. When we talk about PEM style technologies or electrolysers, there's where we again have that makeup system that's necessary for the electrolysis process to work. But we also have a recirculation polishing loop typically going through the electrolyzer. So in PEM style, we typically see better water purification requirements, often above 15 meg or 0.0, what is it, 66 microsiemen, somewhere in that neighborhood. So that would be the makeup system requirements. So again, we would need to make sure that we have the right deionization requirements in order to hit type 1 or type 2 water feeding the PEM style process. And then the recirculation bath is the other area where we need to continuously polish that water to ensure that we're getting the right water feeding into the electrolyzer itself. And that can be a higher flow rate. It could be 10, 20, even 30 times higher than the makeup water requirements in order to ensure efficiency and proper cooling because those loops typically run hot. When it comes to like a solid oxide, I think, we're still learning, it's evolving. And I think to a certain extent, I could say that for what we're seeing for water requirements across the board, there are certain instances where, depending on the electrolyzer company, there are specific water requirements that they want to hit in order to ensure that their process is running efficiently and long term.